So the second part of our mass spectrometer, we already have our particles of a known charge, so in this case they are singly ionized, so the charge is the elementary charge, and known velocity, thanks to our handy dandy velocity selector. They came out of there with a specific velocity that we know equal to the electric field over the magnetic field from the velocity sector. So the next trick is we take the charges and now we pass them into a new magnetic field, or it really could be an extension of the old magnetic field, but a magnetic field only, so no electric field now. And so the magnetic field is still going to exert a force on our charges as they go in there, but now nothing else is going to bounce, because what we want these things to do is we want them to turn, because the radius of their turn is going to depend on the force, which depends on the velocity, which all of the particles have the same velocity, and also the mass. And so mass spectrometer, we want to separate these things by mass. And so our charged particles are going to enter this magnetic field, and I've chosen to make this one out of the page to differentiate it from the first one. It could be any direction and make these things turn in any direction. So a charged particle moving in this magnetic field would experience a force. Well, thumb goes to the right. This time your pointer finger would come out of the page, meaning your middle finger, the force, would be directed downward. And so velocity, magnetic field, force would be directed downward. And so if we drew a free body diagram of this thing as it enters the field, there's its velocity. The magnetic force on it would be directed straight down. So as this thing turns, obviously the velocity is going to change and the magnetic force will change with it. And so this thing is going to move in a circle. So if we kind of trace out the path that such a thing could possibly move through, you'll kind of do something like that, moving like a half circle. So the next trick is we just take some sort of detecting device. And detecting device sounds really nebulous and black box. Really, you know, the original design of these things, this detector would just be a piece of photographic film. So I'm just going to write on here, film. Like from a camera. And so wherever the particles landed on the film, when you went and developed the film, you would see like a bright spot. And so the position on here we can measure, and we can get the radius of curvature of this thing, because this distance here would be the radius. Let's just call that big R for the time being. And different massed particles would travel through different radiuses. And so one particle might travel through this semicircle, whereas another one might make a wider semicircle and land there. And so by judging how far the radius is, how far these things turn based on how heavy they are, heavier would be a wider term, we can figure out how heavy they are. So entering the field, the magnetic force in this case, FB, is centripetal. And so we can set the quantity QVB equal to the quantity mv squared over r. Call that big R. Excuse me. Okay, so you could do a little bit of canceling, like you could cancel this V with one of those V's. So we can say Q times B, and then multiply both sides by R, get rid of the fraction, equals M times V. And so we could just divide both sides by M to get the, or excuse me, by V to get the mass. So QB times R over V equals the mass. And so Q we know based on how we charge these particles. And if we didn't know it, we could still get the ratio of mass to charge. So if we did not know what Q was, for whatever reason, how we got these ions to begin with, we could still go the mass to charge ratio would have to be BR over V. And we could then use some other means to find the charge. And so that's one method of using this machine. If we don't know what the charge is, we can still get the mass to charge ratio, which is how we first started learning what an electron was, like with this quantity right here. Magnetic field, we can get that by how we create the magnetic field. And so if we made this field with a current carrying wire, that would be the mu naught I over 2 pi r equation. R, that's easy to measure. We take our film out, we measure how far away from the entrance point the thing's smacked into the film. And then the velocity, that we measure with our velocity selector. So these two pieces together are what we refer to as a mass spectrometer. It is an extremely important device to understand and eventually in your science career possibly even use. Like, this is kind of a key device in understanding the nature of things because it allows us to get the mass of really, really small particles. So on your formula chart, you see the mass of an electron. This is how we know the mass of an electron. So now you should be well equipped to do the questions on our assignment today regarding the mass spectrometer. And since this is new, trying to teach it this way, please let me know what needs to be clarified. Till next time, ta-ta.